Assalamu alaikum, students. Today I'm going to revise with you the A levels grade 12 P3 9709 formulae of differentiation. And also, I will try to give you some background information of differentiation, which is very important for the grade 12 exam. Okay, so let's start. Bismillah ar-Rahman ar-Rahim. Differentiation. What are the things you need to know? Number one is the power rule of differentiation. You can write d over dx at the back of any function. It means you want to take the derivative. Suppose I have x raised per n, very simple function. So the differentiation of x raised per n, the answer will come to you n x n minus 1. This is the basic power rule of differentiation. Now you can um, use the differentiation power rule in complicated functions. But before that, you need to know some important results. The differentiation of x is equals to 1. The differentiation of sorry, the differentiation of constant is 0, and the differentiation of so as you see, differentiation of constant is 0, differentiation of x square is 2x. In the same way, you can apply the rule of differentiation. Let me write the complicated ones. If I want to take the differentiation of 3x raised power 7 minus 5x squared plus 8x plus 9, so the differentiation will be applied for all these terms. So it will give us 21x power 6 minus 10x power 1 plus 8 and plus 0. So this is just basic differentiation. And the A2 students, they don't have any problem in this type of differentiation. Um, Another thing which I want to mention it here, in A2 course, what are the important functions we have? We have to find the differentiation of an exponential function. Suppose we have e raised to power 3x, we want to find the differentiation. The exponential functions is such a function, its differentiation and integration is always the same. So I'm going to write my answer as e raised to power 3x, but don't forget to apply the further derivative of the power. So the further derivative of the power is 3. So So I can say e raised power 3 into 3 e raised power 3x is the differentiation of e raised power 3x. It's pretty simple. I can write another derivative, for example, e raised to power 5x plus 1. Again, e raised to power 5x plus 1 will come as it is, and the further derivative of 5x plus 1 is 5. So final answer is 5 e raised to power 5x plus 1. So this is exponential function derivative. Generally speaking, if you have any function, if you want to take the differentiation, you will copy it as it is, and you will take the further derivative of the function, which is here in the power f dash of x. Next thing, which is in your course, differentiation of log functions. Okay, guys, log function. The differentiation of the log function is you need to reciprocate your argument. This is your argument. So what I'm going to do to apply the differentiation of ln, I will reciprocate the argument. 5x squared plus 2x plus 3 will come in the denominator, and then we take the further derivative of the argument, which is 10x plus 2. So general rule of ln function is if you have ln of f of x, So first you write 1 over f of x and then times with f dash of x, which is the derivative of the argument. After exponential function, logarithmic function, now we come to the derivatives of trigonometric functions. So sine of 3x. So the derivative of sine is cosine, and 3x, the argument will stay as it is. Now the further derivative of the argument, which is 3. So my final answer is 3 cosine of 3x. The general rule of sine function. So we will write sine, the derivative of sine function is cosine of f of x, and then the further derivative of the argument. Next, the derivative of cosine of 3x. The cosine, since it starts with c, every trigonometric function starts with c, it gives you the minus sign. So I'm going to write here minus sine 3x, and the further derivative of 3x will give you 3, and in simplified form I'll write minus 3 sine of 3x. General rule, if I have a cosine function applied on any function which is staying as an argument, so the derivative of cosine is minus sine f of x, the argument will stay as it is. Now the further derivative of the argument. Next in your course is derivative of tan function. So the derivative of tan is, tan gives you secant square, argument stays as it is. Now the further derivative of argument 3x is 3. Simplified answer is 3 secant square 3 of x. General rule, if you have a tan function applied on any function which is in the argument, you write secant square f of x and then times with f dash of x. 11th, after doing the trigonometric functions, do we have the reciprocal trigonometric functions differentiation included in our course? No, it's not included. Now let me check. There is one more case: differentiation of inverse tan of x. That is a new thing added in the course. So that is 1 over 1 plus whatever you see here, the argument, you write it here 1 plus x squared, and then let me just erase this one because I was doing the differentiation of inverse tan. So the inverse tan give you 1 over 1 plus x squared, and the further derivative of the argument, which is x, and that is to be 1. Let me write one question. Find the derivative of inverse tan of 3x squared plus 2. Now what I'm going to do, I will reciprocate the argument 1 plus 3x squared plus 2 whole squared, because whatever I see here, I have to write it here under the square. Then times with the derivative of the function, which is 6x. In simplified form, I'll write 6x over 1 plus 3x squared plus 2 whole squared. So this is the derivative of inverse tan function. And then do we have any other trigonometric function left? No, khalas. So now we go to the product rule of differentiation. Product rule of differentiation. In product rule of differentiation, when the two functions are multiplying, f of x function and g of x function, so we will always get two terms, and first term has two portions. Number one, you will copy the f of the first function f of x as it is, but you take the derivative of the second function here, which is g dash of x, and you repeat the same procedure here. In the second box, In second term, you write g of x as it is, and you take the derivative of the first function. Let me give you an easy example. For example, if I want to find the derivative of x squared and sine of x, now my first function x squared, I'll keep it as it is. The derivative of sine x is cosine x, and then I will keep the sine x as it is. The derivative of x squared is 2x. So the final answer comes to me x squared cosine of x plus 2x sine of x. This is um, the product rule of differentiation. We took it. Now we go to the 13th one, which is called quotient rule of differentiation. The quotient rule of differentiation is also very simple when we have two functions but they are dividing on each other. F of x is divided by g of x. In such a case, you write the denominator function g of x under the square, and then you will again do the same thing as like what you did in differentiation, but now you will have a minus sign in between. Your first term will be divided into two parts, and the second term will also divided into two parts. Now, since you write the g of x down, now you write here g of x as it is. Now, the derivative of the numerator, f dash of x. Now, you copy here f of x function and the derivative of the g function, right? So, this is a quotient rule. Let me try to apply it in one example. Differentiation of x squared over sine of x. Now, sine of x under the square, you keep sine x as it is. The derivative of x squared is 2x minus, then what will you do? You'll write x squared as it is, and the derivative of sine of x is cosine of x. So in simplified form, 2x sine of x minus x squared cosine of x sine square of x. That's the final answer for the quotient rule of differentiations. Now the next one is in your course is the which is called implicit differentiation. Implicit differentiation is when we have an implicit function and we want to find dy by dx. Implicit means when the x and y are mixed uh, in one expression. Let me write an implicit equation: x squared plus 2xy plus y squared is equal to 3. So this is called an implicit equation. Why it is called implicit equation? Because it is the mixture of x and y, and you cannot easily make y as a subject. So guys, we want to find what? We want to find dy by dx. To get dy by dx, we have to differentiate every term. So this the derivative of x squared is 2x. Now it's not easy, the differentiation of 2xy. Basically, I need to apply the product rule. I have two terms, and I have 2x and I have y. So apply the product rule, which I have just discussed with you. Keep the 2x as it is. The derivative of y is not 1, it is dy by dx. Then you leave y, and the derivative of 2x is just 2. The derivative of y square is apply the power rule. The power goes back, and you subtract 1 from the power. It is 1. The further derivative of y is dy by dx, and then the differentiation of 3 is 0. Now 2x plus 2x dy by dx plus 2y plus 2y dy by dx. As you remember, we wanted to make dy by dx as a subject, and the remaining terms will be shifted to the other side. So we take dy by dx common from the two terms which contain dy by dx. What is left inside the bracket? 2x plus 2y and on the other side we sent the 2x and the 2y. So minus 2x and minus 2y, and then the dy by dx comes to me minus 2x and minus 2y over 2x plus 2y. You can also write it in simplified form, which is minus x minus y over x plus y. So this is implicit differentiation. Next, we have parametric differentiation. Parametric differentiation is done when we are being given um, parametric equations like x is equals to sorry, y is given in terms of t. Suppose he said it is sine of t, and x is e raised to power 2t. Now I want to find the dy by dx. So guys, you can see now your y is given in terms of t. Your x is given in terms of t. Such a pair of equation is called parametric equations. These parametric equations will be dealt separately by from here I will find dy by dt because the variable on the other side is t. So dy by dt, it gives me cosine of t, and from here I will find dx over dt, and it will give me 2e 2t. Now, after finding dy by dt and dx by dt, I want to find dy by dx. So dy by dx, applying the chain rule, I write dy and dx here. There I will write dt. And now uh, right here, what is dy by dt? I wrote it, that is cosine of t. And what is dt by dx? Since dx over dt is 2e 2t over 1, so I will write 1 over 2e 2t because it is reciprocated. So in the simplest form, I'm going to write cosine of t over 2e 2t. That is my dy by dx. So as far as the rules of differentiation of in A2 course are concerned, I discussed with you. Now we come to the application part. Applications of differentiation, which are included in your course. So 16th one, applications. Guys, number one is gradient of a tangent. Gradient of a tangent and normal. Boys, dy by dx, which you find it is the gradient of a tangent. Sometimes grade tangent to the curve. Sometimes the examiner asks you find the equation of a curve. So you have to find dy by dx. This is m, and minus 1 over m or minus 1 over dy by dx. This is called gradient of normal to the curve. Let me very quickly explain you. This is the curve, and this is the point where you draw the tangent. So the gradient of the tangent is dy by dx, and if you draw a perpendicular to this tangent, so this line is called a normal line to the tangent at this point, and its gradient is, the gradient of the normal is minus 1 over gradient of the tangent. So now you understand what is the meaning of tangent and normal. Next thing in in your course, increasing and decreasing functions. Increasing and functions. So if dy by dx is greater than 0, it means that your f of x is increasing in that interval. If dy by dx is less than 0, your f of x function is decreasing, right? The next is stationary points. Stationary points or turning points, when the dy by dx is equal to 0. You get the value of x. That value of x is the x coordinate of the stationary point. But how can I say which point is maximum or minimum? So the nature of the stationary points, so nature of the stationary points can be found out by finding the second derivative. So if you find the second derivative and you plug here the value of x, which you put it here, which you find it here, you put it in the second derivative. If the answer of the second derivative numerically is positive, then this is a minimum point, and if the numerical answer of second derivative is negative, then it is a that stationary point is a maximum point. So these are the important things required. I think rates of change is not very important. If any question related to that comes in the past papers, I will discuss with you. Here I have few questions to discuss with you, which are on differentiation. Let's try to do them, which came in recent past papers. You see, guys, he gave you the equation of a curve, and he said you need to find dy by dx. So basically, this is an implicit equation: x raised by 3 plus 3xy squared minus y power 3 is equal to 5. And we want to differentiate it. So the derivative of x cube is 3x squared. Now the derivative of 3xy squared, we need to apply the product rule, leave 3x as it is, and the derivative of y squared is 2y dy by dx, plus, now leave the y squared, the derivative of 3x is 3. So this is the product rule applied on this. I hope you guys clear. Now minus the y cube, apply the power rule, 3y squared, further derivative of y is dy by dx, and the derivative of y 5 is 0. Open the brackets. So 3x squared plus 6xy dy by dx plus 3y squared minus 3y squared dy by dx is equal to 0. Now keep the dy by dx terms on the left by taking dy by dx common. 6xy minus 3y squared, and send the other terms on the other side. So minus 3x squared minus 3y squared. Finally, I'm going to get dy by dx is equals to minus 3x squared minus 3y squared over 6xy minus 3y squared. Now, all of you, please check that. Uh, is there anything going to be cancelled? So I think result is matching. Only one thing you need to take care of: can you up and down, can you multiply every term with the or divide every term with -3? And here I'm gonna divide this with -3 and this one also by -3, because we have more minuses than plus. That's why I want to convert them into the plus sign. Okay, so dy by dx. So the first term will become, after dividing with -3, it leaves you x squared. Then the next one will give you plus y squared. And then finally, we will be having here minus 3xy. And then here we will be getting y squared. And this is the result which we wanted to get for this implicit differentiation. Let me check. When I divide it with 6 with 3, it has to be 2. So it is minus 2xy. Yes, now it's perfect. Next question is, which he will actually relate it with the application. Find the coordinates of the points of the curve where the tangent is parallel to the x-axis. Guys, when this is the curve and your tangent is parallel to the this tangent is parallel to the x-axis, but he said that the tangent is parallel to the y-axis. So let me see what type of graph it is. Suppose if you have, let me draw it here. This is the graph, for example, where the tangent is parallel to the y-axis. When the tangent is parallel to the y-axis, what happens to the gradient? Any line parallel to the y-axis, any line parallel to the y-axis, because the gradient of the y-axis is infinity. So the denominator of the fraction has to be equal to 0. So let me check what is the gradient I have found for the tangent. Let's check. We found dy by dx. Our dy by dx came to us x squared plus y squared over minus 2xy plus y squared. Now, as you know, if I put the numerator equal to 0, if I put the numerator equals to 0, then it means the tangent is parallel to the x-axis. But if I put the denominator equals to 0, then the tangent will be parallel to the y-axis. So since I need the tangent parallel to the y-axis, so I'm going to put my denominator equals to 0, minus 2xy plus y squared is equal to 0. Let us try to take y common. So minus 2x plus y is equal to 0. It gives me two values, y is equal to 0 and y is equals to 2x. Can we plug these equation into the original equation? The original equation is given to me x cubed plus 3x squared xy squared, x cubed plus 3xy squared, x cubed plus 3xy squared minus y cubed is equal to 5. Minus y cubed is equal to 5. Can you plug it? When you plug this value, it gives you x cubed is equal to 5 and x is equal to the cube root of 5. So this point is cube root of 5 comma 0. One point where you draw the tangent, it will become parallel to the y-axis. The second one, we need to again plug it. So x cubed plus 3x, in the place of y, we substitute 2x. 2x cubed is equal to 5. We got x cubed plus 3x, 4x squared minus 8, x cubed is equal to 5. We got x cubed plus 12x cubed minus 8, x cubed equal to 5. It gives us 5. X cubed is equal to 5 and x cubed is equal to 1 and x is equals to 1, which gives you y, which was 2x. So now y is 2. So that second point is 1, 2. So these are the 2 points where the tangent is parallel to the y. Find the coordinates of the points. So the examiner mentioned find the coordinates of the points. So the 2 points we have found it. It came to us cube root of 5 comma 0 and 1, 2. Um, I want to solve one more question which is related to differentiation. So you can see this question. He gave it to you an equation of a curve y equals e raised by 2x sine of x plus 3 cosine of x, and he wants the x coordinate of the stationary point. So how can we find the stationary point? We need to find the dy by dx first. So y e raised by 2x, open the bracket, or if you don't want it, you can leave it as it is. I'll just start applying the differentiation. Dy by dx leave e raised by 2x. The derivative of sine x and cosine x is, and then e2x times 2. Since we want to find the stationary points, we put it equal to 0. E raised by 2x cosine of x minus 3 e raised by 2x sine of x plus 2 e raised by 2x sine of x plus 6 e raised by 2x cosine of x is equal to 0. You take e raised by 2x common, so cosine of x minus 3 sine of x plus 2 sine of x plus 6 cosine of x is equal to 0. So e raised by 2x cosine is 7 cosine of x minus sine of x is equal to 0. It leaves you either e raised by 2x is 0 or 7 cosine of x minus sine of x is equal to 0. This is not possible since e raised by 2x should be greater than 0. So 7 cosine of x is equal to sine of x, and 7 is equal to tan of x. So he said find the x coordinate. You can write shift tan. Your calculator must be in radian mod. Yeah, shift tan 7. It gives you 1.43. 1.43. So x is equal to 1.43. Determine whether the stationary point is maximum or minimum. We need to take the second derivative. Guys, did we simplify the result? I think the simplified result was here. This one was the simplified result of dy by dx. Can I copy it here? So yeah, any dy by dx, I found it. E raised by 2x, 7 cosine of x minus sine of x. Let's take the derivative again. I'll take the e raised by 2x common. So we have minus 7 sine of x minus cosine of x plus 14 cosine of x minus 2 sine of x. Further simplified, it gives you minus 9 sine of x plus 13 cosine of x. Now you need to plug the value of x here and check what the answer comes. So I'm going to substitute now e raised by 2x. Now in the place of x, we need to write the value 1.43 times minus 9 sine 1.43 plus 13 cosine 1.43. We got a negative answer from the calculator. It gave us, so since we got a negative answer, it means this gives us a maximum point. Thank you, boys.